we are now talking about UI accessibility, reusable UI accessibility written in Rust. And for that, we want to welcome Matt Campbell. Matt worked for the past 2 decades, I guess, on 2 Windows screen readers, one with Microsoft. He developed the third-party one and is now implementing cross-platform accessibility in Rust and beyond. The most important information, though, is that Matt is an avid karaoke singer, and he has memorized over 80 songs for karaoke. What's your favorite song, Matt?
Everybody Wants to Rule the World by Tears for Fears.
Amazing. Let me tell you, you are at home in the Rust community. The Rust community are avid karaoke singers as well. So if anybody of you has been at one of the Rust fests in the past, karaoke was a staple there. But yeah, before we are going to sing karaoke, let's hear about your accessibility. Have a big round of applause for Matt.
Thank you. It's great to be here. So I'm here to talk about an open source project called AccessKit, which is written in Rust and designed to be used in other languages as well. So what is AccessKit? It's a library that GUI toolkit developers can use to implement accessibility. And by accessibility, I specifically mean here exposing the content and structure of your UI in such a way that it can be used by people who use certain assistive technologies, including screen readers for blind people, screen magnifiers for people with low vision, and certain alternative input methods such as switch-based navigation and voice commands. AccessKit aims to eliminate for the toolkit developer a lot of the incidental complexity of implementing accessibility from scratch. And it does so by providing a cross-platform abstraction over the various platform-specific accessibility APIs. These APIs tend to rely on fairly esoteric platform-specific technologies or specific programming languages. For instance, the Windows UI Automation API is based on Microsoft's Component Object Model, or COM. macOS Accessibility is based on Objective-C. The accessibility protocol for GNOME, KDE, and other free desktops on Linux and other free Unixes is based on Dbus. And Android accessibility requires you to write in Java. So AccessKit encapsulates all of that into a single cross-platform abstraction. And in fact, AccessKit is already usable across all of those platforms that I mentioned. And as I said, it's written in Rust, but designed to be used in other languages as well. And I'll be discussing and demonstrating that. So with that, I'm going to play a couple of pre-recorded demos, which I will narrate as they play. For this first demo, I'll be showing an application using the Xylem Rust GUI toolkit. And specifically, I'll be showing the Xylem To-Do MVC example application on Android using the TalkBack screen reader.
My next task, edit box. Double tap to edit text.
So the TalkBack initially puts the accessibility focus on the first widget on the screen, and there's a highlight rectangle around the widget with the accessibility focus. Now I'll swipe right to the next widget.
Add task button. Double tap to activate.
So now the focus is on the button, and we'll double tap to activate it. And it did add the task to the to-do list and clear the edit box, although AccessKit on Android doesn't currently have a way to announce such changes. Now we'll swipe back to the edit.
Edit box. Double tap to edit text.
And as you can hear, it's now cleared. We'll swipe forward to the first checkbox in the to-do list.
Add task button. Double tap to activate. Not checked by milk checkbox. Double tap to toggle.
And we'll double tap to check it.
Checked.
It did announce that because it's a change in the accessibility focused widget. We'll swipe back to the edit.
Add task button. Double tap to activate. Edit box. Double tap to edit text.
And we'll double tap to start editing. And for speed, I'm entering some text using a physical keyboard. That's why it's not showing the soft keyboard.
T-E-S-T. Test. T-A-S-K.
And those echoed characters in the echoed word are based on text change events that AccessKit is firing. So the application is updating the accessibility tree as you enter text, and then AccessKit is firing those events. Now we'll start swiping up to move backward through the text. Wait for the demo to catch up with me. I left too much space there.
K S A T
And now we'll start swiping down to move in the other direction.
T A S K, end of field.
And the text cursor is also moving as we move through the field with TalkBack. So that's a demo of a simple Android application made accessible with AccessKit. And wait for the demo to finish playing. So to clarify a few things before we proceed, AccessKit does not automatically handle everything that's needed to make applications accessible for various different disabilities. For instance, it's the toolkit or application developer's responsibility to take care of different color schemes or different display styles generally. So providing high contrast if that's what the user has indicated they need through system settings, and light versus dark mode. And of course, that one is pretty common, pretty well expected of modern applications anyway. Also, and this is especially important on desktop platforms, keyboard commands are the toolkit's responsibility. Now, it's true that screen readers provide some keyboard commands of their own, but accessibility is about more than just screen readers. And even there, the toolkit is responsible for certain things like navigating with Tab and Shift Tab, or in some cases, moving through a list control with the arrows. Also, AccessKit is completely disconnected from the rendering part of your toolkit, so AccessKit in itself doesn't have any effect on the way that your UI looks. Now, there are some things that do have an effect on the appearance, like the highlight rectangle in the previous demo, but those things are typically handled by the platform or an assistive technology as either an overlay or a post-processing step with help from the compositor. And you can use AccessKit with any rendering technology. So whether you're using WGPU or OpenGL or Vulkan or whatever, you can make your toolkit accessible with AccessKit. So I mentioned exposing the content and structure of your UI, and here I want to show a partial and simplified example of what that means. So this is called an accessibility tree, and it's a hierarchy of UI nodes. And if you're at all familiar with the document object model, or DOM, from the web platform, then this is conceptually similar. Each node has an ID, a role, one or more properties, and optionally child nodes. One property that I'm not showing here is the bounding rectangle, but that is what allowed that highlight cursor to work. So at the root, we've got our window node, and then the window has a child node for each of the widgets. The text input node has a text selection, and I've omitted the details of how that's represented, but it's there. And then the text input has one or more text run child nodes. A multi-line text input would have at least one text run per line. And when you get into things like rich text and bidirectional text, then you often have multiple text runs per line. And then finally, the button node has a label node as its child, because that is how the widget tree is represented in Xylem. The label is a child widget of the button. So that should give you a little more concrete idea of what exactly a toolkit needs to expose through AccessKit. So now we're ready for our second demo. This one is not directly written in Rust. This is a simple game using the Godot game engine, which recently integrated AccessKit across the 3 major desktop platforms. So we have a game engine with accessibility built in. And for this demo, the co-developer of AccessKit, Arnold Lubria, took an existing tic-tac-toe game that was written using the Godot engine, and he made it accessible with AccessKit. So for this demo, I'm using the NVDA screen reader on Windows.
Tic-tac-toe window, blank, center.
So we're in the center of the tic-tac-toe board. When the window comes to the foreground, AccessKit fires a focus event, which indicates which node in that window currently has the focus, and that is what triggered that screen reader announcement. Now we'll press the down arrow to move to another place on the board.
Blank, bottom.
So that down arrow keystroke was handled by the application, which moved the keyboard focus. It updated the accessibility tree, and in response, AccessKit fired a focus event, which triggered the screen reader announcement. Now we'll press enter to fill that spot on the board. Wait for the demo. Come on. I left too much space.
Cross, bottom. Your opponent plays bottom left.
And that specific announcement was provided directly by the application using what we call a live region. It's similar to the concept with the same name in the web platform. So now we're going to up arrow to move back to the center.
Blank, center.
And we'll press enter to fill that spot on the board and see if we
Cross,
can...
center. Your opponent plays top.
It's not going to let me do a vertical row, so we'll do right arrow to try the center right.
Blank, right.
And we'll press enter to fill that spot on the board.
Cross, right. Your opponent plays bottom right.
Okay, it's not going to stop me from doing that horizontal row, so I'll move left back onto the center.
Cross, center.
Which is the one we already filled, so we'll left arrow again.
Blank, left.
And we'll press enter to fill that spot.
Cross, left. You win.
And again, using a live region, the application announced that we won. So that is a simple demo of a game made accessible using the Godot engine and AccessKit. So now I want to talk about what I think is the most distinctive feature of AccessKit, which is what I call the push-based architecture. So I'll describe this by way of comparison to the way that the platform accessibility APIs work. The platform APIs are pull-based, which means that they rely heavily on callbacks to traverse the accessibility tree and query information about properties. And those callbacks, as I mentioned, are usually implemented using some kind of object-oriented interface. With AccessKit, on the other hand, the toolkit developer populates a tree update data structure with one or more of those AccessKit tree nodes, and it initially provides a full accessibility tree up front, in which case it also includes a different structure with top-level information about the tree, and then after that, it provides incremental updates, and for each tree update, the toolkit calls a function in AccessKit which effectively pushes that update to AccessKit, which then maintains a tree in memory and implements the pull-based platform APIs. This model is based conceptually very strongly on what Chromium is doing internally with the way that it pushes tree updates from the sandboxed renderer process to the unsandboxed main browser process, which is what actually implements the platform accessibility APIs. Now, in the case of Chromium, it's actually using IPC and serialization. In AccessKit, it's just passing data structures into a function, but it's conceptually very similar. And what this means for UI toolkit developers is that sending an accessibility tree update is conceptually similar to drawing a new frame of the UI. And in fact, you can put that in the same place in your UI lifecycle. So at the same time that you're drawing a new frame, you can push the corresponding accessibility update, and it's way less reliant on callbacks than the platform APIs are. And in fact, the main callback that you need to implement is what we call the action handler callback, which handles things like when I was double tapping those buttons in the Android demo, that was handled through a callback where AccessKit calls into the toolkit, and that is conceptually just like your regular event handler. So it should feel pretty familiar to a toolkit developer, much more so than the platform accessibility APIs. This also means that this model works quite well for immediate mode toolkits, such as the popular eGUI toolkit, which in fact was the first toolkit to get a full-featured accessibility implementation using AccessKit. And in particular, since immediate mode toolkits tend not to maintain a lot of state between frames, the toolkit can just push a tree update at the same time that it's drawing a frame. And in fact, the toolkit can push a full tree update every time, and AccessKit will do a diff between that and the existing tree to figure out what changed and which platform events need to be fired. So now I'm going to dive a little deeper into the latest platform adapter or backend that we used to that we added to AccessKit, and I'm going to discuss how we took a layered approach to balance two of our goals for the project. And we have a similar layering going on with the Windows and Mac OS adapters. So at the lower layer, we have the adapter struct, which has functions corresponding to the Java methods that an Android view would need to implement to be accessible. And this is designed for cases where you are writing your own Android view subclass and you want to directly and with as little overhead as possible integrate accessibility. And one example of an Android view implementation that uses this is I've been working on a new crate called Android View, and a full discussion of Android View is beyond the scope of this talk, but I've provided a link here to the current repo, and it's basically designed to be a low overhead, maximally flexible way of implementing an Android View in Rust, whether it's for a full application or just an embedded piece of UI. And there are two demos currently in that Android View repo, and they both use the AccessKit Android adapter at this level. Now, at the higher level, we have another struct called injecting adapter, which is designed for cases where you're not implementing the Android View class yourself, and you need to just retrofit accessibility onto something that already exists. And in that case, we handle the Java and JNI glue code for you. And the downside to that is that there's some overhead of forcing things to be sent to the UI thread. So it works regardless of which thread you're doing the tree updates on. So it's not as low overhead as the lower level adapter, but it's designed to be easy to integrate. And an example of where we would use that is if you're using either the native activity or game activity class, which are the two options currently supported by the Winit cross-platform windowing library. If you want to run a Winit-based app on Android, I've got an insect buzzing around here. Go away. Yeah. And so, yeah. So if you're using Winit, then you can make that accessible with this higher level injecting adapter, and that would also be what you would use with a cross-platform library such as SDL once we add Android to our language bindings. So this layered approach allows us to balance two of our goals for AccessKit. On the one hand, we want AccessKit to be as efficient and low overhead as possible. Ideally, as close as we can get to zero overhead, because that's the Rust way, right? Because we know that a lot of UI toolkit developers care a great deal about performance and efficiency, and we want these developers to make their toolkits and applications accessible. But at the same time, we also want to make AccessKit easy to integrate, because we believe, again, that will allow more toolkits and applications to be accessible. And speaking of making more toolkits accessible, even beyond Rust, let's talk about language bindings. So far, we have C So we implemented a wrapper library with a C-compatible ABI, and then used cbindgen to generate the header file. And we have a cross-platform example of using that with SDL. We have Python bindings written using Pyo3 with a cross-platform example using Pygame. I did some work on Java bindings using the crate called JNI and manually writing the corresponding Java glue code. And that was about 2 years ago, so I need to update that. We did a proof of concept Unity plugin a few years ago, and we'll probably rewrite the C# bindings part of that at some point. And then we would also like to do bindings for Go and C++. Of course, you can already use AccessKit from those languages and more using the C API, but we would eventually like to provide idiomatic language bindings as well. And we welcome work on more language bindings, but there's a problem with the way that we're currently approaching language bindings, which is that we're manually developing and maintaining separate bindings for each language. And in addition to just being tedious, it's also error-prone, particularly when you have to implement an ABI in Rust, typically requiring some amount of unsafe Rust code. And pretty much the only language so far where we don't have to do that is Python, because Pyo3 is excellent. Another problem, though, is, and even with the Python bindings, is that the language bindings don't automatically pick up all of the documentation from our native Rust API. So we need to manually copy and adapt doc comments when we remember to do that. There's a couple of different ways that we've been thinking about and talking about dealing with this. One would be to write our own code generator that can generate part of both the base AccessKit crate and the language bindings from some kind of IDL or interface definition language. The other thing, though, that might be even better is to leverage an existing Rust-based tool for generating multiple language bindings. And the leading candidate for that approach is the Diplomat project. We haven't yet made a decision on that. So let's talk about what it's going to take to get AccessKit to version 1.0. So we do want to get to a 1.0 that will allow us to have the same stability guarantees as Rust itself, which means that ideally, once we get to 1.0, we would never have to do a semver breaking release again. But there will probably be more breaking changes before we get there. I realize that some people are frustrated with the level of churn in the Rust graphics and UI ecosystem, but when we get to 1.0, we want to have an API that's as approachable and easy to use and logical and as free of legacy cruft as possible. So bear with us. Stabilization is coming sometime. Until then, we need to do some more work on text support, particularly rich text and some level of hypertext. By rich text, I mean exposing things like font, family, size, and styles, indentation, heading levels, and maybe some other document structure. For hypertext, we at least want hyperlinks. Full HTML support is a very deep rabbit hole, so we probably won't do all of that before 1.0, but we at least want to make sure that we have the right foundations in place. Next is scrolling and virtualized lists. And virtualized lists are large lists where not all of the items are necessarily materialized at the UI level or even have their data in memory at one time. And we want to make sure that these are implemented efficiently and that at the same time they expose the information that assistive technologies expect. Fortunately, the Xylem GUI toolkit that I demoed earlier now has support for virtualized lists, so that's something I'll be working on soon. We have some more widgets to implement, including menus, tables, and tree views. These tend to be desktop-specific widgets. There may be a few more mobile-specific widgets that we need to work on, particularly when we get to the remaining platform adapters. particularly iOS and Canvas-based web applications. Now, to be clear about what I mean by Canvas-based web applications, these are web apps where the whole UI is rendered as one Canvas element, typically using something like WebGL or WebGPU. And these web applications are not going to be perfectly accessible, but we're going to do the best we can within the constraints of current web standards. And finally, we realize that we need more documentation, particularly conceptual and tutorial documentation for toolkit developers who aren't already specialists in accessibility. So, how can the community help? First of all, we want more toolkits to integrate AccessKit. This is what matters more than anything else. We want as many toolkits and applications as possible to be accessible. On documentation, if you feel qualified to help us write it, then that's great. Otherwise, at least ask us questions so we have a better idea of what needs to be documented. And on language bindings, if you want to talk to us about either the custom code generator approach or using something like Diplomat, that would be great. Otherwise, if you want to go ahead and write your own bindings for some language in the current manual style, then go ahead and you can at least do that as an unofficial package, and especially if writing language bindings is going to unblock accessibility efforts for some toolkit or application. So a few special thanks before I finish. Arnold Lubria, my co-developer on AccessKit, who is here at the conference today, and he has done most of the work so far on the Unix/free desktop backend and the C and Python bindings. And he's also been doing code review for my code since very near the beginning of the project. So thank you, Arnold. I'd like to thank Google for providing funding for AccessKit development for multiple years now. AccessKit would not have gotten nearly as far as it has without that funding. And finally, thanks to everyone who has made Rust the great systems programming language that it is, especially for developing projects that can be used in other languages as well. And with that, I'll provide a link to the AccessKit website, my contact info, and my GitHub sponsor page if you're so inclined. Thank you. I'll be happy to take questions.
Thank you very much, Matt. An amazing talk. I loved it. Let's see if we have some questions. Tats is already throwing the catch box, and yeah, caught it. Amazing.
Great talk. Thank you so much. I had a question about terminal user interfaces where you're not in control of the application, the terminal emulator. Would it be possible to use AccessKit in applications like that?
I've actually thought about this, and I think what might be, well, for at least for cases where the terminal emulator developer would be willing to cooperate. Of course, we've got at least a couple of terminal emulators written in Rust. It might be feasible to add some new terminal escape commands for sending serialized accessibility tree updates through the PTY and or the SSH connection, as the case may be, and having the terminal emulator expose that to the screen reader or other AT. I mean, I've got a few other projects that I would like to work on someday. This is one of them, but I have given it a little thought.
Cool. Thank you.
Thank you. More questions? Okay, I'm not seeing the box anymore. Oh, there it is. Cool.
Thanks for the talk. What I was wondering while I was listening to your talk was how can people who are new to accessibility test whether their programs can be used by people who need extra help to work with your program?
Right. So all of the major operating systems have a free built-in screen reader now, and I can just go down the list. With Windows, you can turn on narrator with Windows Control Enter. On Mac OS, you can turn on VoiceOver with Command F5. On GNOME, you can turn on Orca with Alt Super S. On iOS, you can turn on VoiceOver it's in settings somewhere. Same with TalkBack on Android. And I realize that to some extent, I'm asking you to like jump in the deep end and learn a whole different way of using your device by doing that. But that is really the way to get the actual experience. There are other tools that you can use to just make sure that your accessibility tree is correct. There's Accessibility Inspector on Mac OS, Accessizer, that's ACCER, on GNOME, and Accessibility Insights on Windows.
And are there also tools for integrating it in a CSCD?
One thing I can point to, if your GUI toolkit of choice supports it, is there is actually a Rust crate called Kit Test, which allows you to do headless GUI testing using AccessKit. So it doesn't like set up the full end-to-end setup with the actual platform accessibility API and the and an actual assistive technology, but it does allow you to test in a convenient way that your accessibility tree is what you expect it to be.
All right. Any more questions? I see a hand over there.
Wait, I can hear myself. Really great talk. The question I had, sorry, the delay is messing up my voice. So it seems like this is designed for exposing like the accessibility information to the platform itself. And I'm curious what like downstream assistive technologies, like how you'd be able to implement that across platforms, maybe like desktop in particular. So like if you wanted to actually be able to read the accessibility information and design your own technology.
So like if you wanted to implement your own screen reader or the like?
Yeah.
I don't have anything to help you with that. You would still be on your own working with the platform-specific APIs. There are Rust libraries that you can use to help you with that. For instance, the Windows crate on Rust, obj_c2 on Mac OS, ZBus for Linux. But you're still pretty much on your own working with the platform APIs directly.
Right, I guess we have time for one more question. I guess you see the hands better than I do. Oh, there's the box.
Thank you very much for the talk and for working on AccessKit. You have in front of you a significant part, a lot of people from the community and from the project. Are there things that the toolchain, the community could be doing for making the life easier on not only the end users, but rather the developers that want to use Rust that need accessibility?
Nothing immediately comes to mind for me. I mean, you're already providing like a command line tool with Rust up, and like command line is about as accessible as it gets, and people can already use whatever IDE they want. A lot of blind programmers that I know use Visual Studio Code, so that's already in pretty good shape.
All right, thank you very much. Matt, thank you for your talk. It was an amazing talk. It was an important talk, I think. I didn't realize for half the time that those demos were pre-recorded. I actually thought
I said they were.
Oh yeah. But amazing. I think you will be around for the rest of the conference. So if somebody wants to catch up with you,
my plan is to head to the GoSim. So we have a table in the GoSim spotlight area. So I think I'm probably going to be heading there like shortly after this.
Amazing. All right. So please give a final round of applause for Matt.